Today I'm going to show you guys how to solve an equation that contains multiple variables. And keep in mind, when we simplified algebraic expressions, we used PEMDAS, or please excuse my dear Aunt Sally, and we went from left to right, parentheses, exponents, multiplication, division, addition, subtraction. When we solve equations, we're actually going to solve them in reverse order. So you start with the addition, subtraction, and move all the way up through parentheses. Alright, so we're doing it in reverse order. Now, knowing how to solve these equations, we have three of them here. For each one of the variables, so knowing how to solve for m and then a, or f and then a, and so on, it's important because knowing one formula can get you here, two other additional formulas. Also, solving for specific letters or variables maintains accuracy when you're doing application or word problems. All right. So looking at, we have force equals mass times acceleration. If I wanted to solve for m, so I want to get m by itself, we need to get rid of this a. All right, and this a is not being added or subtracted, it's actually being multiplied. And as we learned before, how do we undo multiplication? We're going to divide. So we're going to divide both sides by a. We're going to divide, if we do it on one side, do it on the other to maintain this balance so they're equal. The a's on the right side are going to reduce to a 1, and that's what we want. We want our leading coefficient to be a 1. And now we have force divided by acceleration is equal to mass. And you could have easily solved this equation for acceleration just by dividing by m on both sides. And if you wanted to, you could just rewrite it as mass is equal to force divided by acceleration. Right. In this next example, we're looking at pressure is equal to force divided by area. And we're actually going to solve this for both force and area. The first one we're going to solve by force. We have force divided by area. So how do we... Actually, let me rewrite this. Pressure equals force divided by area. How do we undo division? We do multiplication. All right, we're going to multiply both sides by a. Multiply this side by a as well. These will reduce, and now we have pressure times a is equal to force. All right, and we're done. Or you could write force equals PA if you wanted to, with a multiplication in there. If you were to solve for a, this initial equation, it's a little bit trickier. I mean, once you're right here, you could actually divide both sides by p and get a by itself. But to start off initially, what I recommend to my students is to write p over 1 is equal to force divided by area. And what we're actually going to do here is cross multiply. Remember, if we ever have two fractions set equal to each other, we can cross multiply. So we'll have p times a is equal to f times 1, which is the same exact thing if you notice over here. And now what we'll do is we'll divide both sides by p, divided by p. These will reduce, and we have a is equal to f over p. All right, so we solved it for both f and a. All right, and let's move on to this last equation. In this last example, we have temperature of Fahrenheit. So Fahrenheit is equal to 9/5 times the temperature of Celsius plus 32. And so suppose we want to solve this equation for Celsius, the temperature in Celsius. We have addition here, and we actually have multiplication and division going on right here. So according to PEMDAS, we're doing it in reverse. We want to take care of our addition and subtraction first. You always look at the sign in front of what's being added or subtracted. All right, this is a positive 32, so what we're going to do is subtract 32 from both sides. Subtract 32. These are unlike, you really can't do anything with them, so we're just going to rewrite t sub f minus 32 is equal to 9/5 t sub c. Right. And now remember, we want to solve for this. How do you undo multiplication of a fraction? You're going to multiply by the reciprocal, 5/9. Do it to that side. You have to do it to the entire other side. You can't just pick to do it one part or the other. You have to do it to the entire thing, so throw your parentheses in there. And now, these will cross cancel, reduce to 1, and we have 9/5, we have 5/9 T sub f, Fahrenheit, minus 32 is equal to the temperature in Celsius. Alright, let's take a look at an application problem, or word problem. Here we have the period of a pendulum is the time it takes the pendulum to complete one cycle. So if your pendulum, say like on a grandfather clock, is starting here, by the time it goes to here, and then by the time it takes it to come back to here, alright, that's considered one period. And the time it takes is given by the formula t is equal to 2 times pi times the square root of L divided by 32, where L is the length of the pendulum in feet. Now suppose if this was meters, you would use 10 here because 32 would be gravity if you're using feet. It would be approximately 10 if you were using meters. So you have a clock whose pendulum has a period of 1.6 seconds, so it takes 1.6 seconds to go back and forth. To the nearest tenth of a foot, how long is the pendulum? And what I'm going to do is I'm going to do the problem by approximating as I go along, and then I'm going to do the problem again, and I'm going to solve for L, and then plug in my numbers afterwards. So I'm going to do it the incorrect way first, and then I'll do it the proper way second, and we'll see that there is actually a significant difference when you do a problem like this. And what we're going to do is we're going to round to the tenth for everything, just to make things easy. So what I did here is I took our formula t equals 2 pi times the square root of L divided by 32, and remember we're using 1.6 seconds as our t, our time, and we want to solve for length. So what I did is I actually went through and I plugged in the numbers as I found them, and I rounded them to the tenth. So I had 1.6 is equal to 2 times pi is approximately 6.3, and I divided both sides by 6.3, and I got 0.3 is equal to the square root of L divided by 32. Squared both sides to undo this square root, and we got 0.1 is equal to L divided by 32. Multiplied both sides by 32, and we got 3.2 is equal to L, so the answer is 3.2 feet. What we're going to do now is actually go through and solve the equation for L, and then plug in our numbers at the end, and you'll see we'll get a significant difference. So now what I've done is I've rewritten the formula, and I've divided by 2 pi, keeping it as a 2 pi, squared both sides to undo the square root, and then I multiplied both sides by 32, so I have 32 times the quantity t divided by 2 pi squared equals L, and then what I did is I plugged in my t value, my 1.6 seconds, right? And we're going to crunch this number. We have 32 times 1.6 divided by 2 pi squared is equal to L, and we get 2.075. What we'll do is we'll just approximate that to L is approximately 2.1 feet, all right, which is a huge difference in 3.2 feet. All right, so it's important. Save your rounding, save your approximations to the end. Always solve for the variable you're looking for, and then plug in your numbers.